Thank you so much. Good afternoon, everybody. I was extremely excited to come here and talk to you today about robotics until Dr. Khatib came in and kind of stole the show for me, talking about the robot he was showing earlier, but I'll try and do it justice, okay? My name is Simone Zatti. Like I mentioned, I'm from Hilti, a company that focuses on construction technology and particularly working on making the construction industry a better place by developing technologies that are driving productivity, safety, and sustainability. And with that, if we can pull up the slides, I'll kind of walk you through the presentation. So we'll talk a little bit about, I'll kind of give you a quick intro about myself, and then we'll talk about who Hilti is, and then what we specifically are doing when it comes to kind of robotics for this industry. So maybe just a quick intro about myself. I've been with Hilti about 12 years. I'm originally from Italy. I started with Hilti 12 years ago in the UK. I was in London and Manchester and then kind of moved out here about 5 years ago. I'm actually particularly excited to be here because day after tomorrow I'm graduating from the Stanford LEAD program, which took me a year to do, so it was a lot of work, but I'm excited to be physically here during the same week. During the years I've been with Hilti, I've been involved on MEP construction, I've been involved with tunneling. I'll give you a quick example here in a second, and also data center construction. So pretty kind of niche parts of the industry. And I've also been very involved with BIM since its inception at Hilti. I was one of the first people who actually hired BIM modelers for Hilti to do some BIM service design, which we to this day now provide a lot of worldwide to some of our customers. Now, who is Hilti? Hilti is a company that started in the 1940s in a little country called Liechtenstein in the Central Europe. And Hilti is really focused on making construction better and driving construction technology on productivity, safety, and sustainability in the industry. And we grew up from being a small kind of operation from Mr. Hilti's garage in Liechtenstein to becoming a global company at 30,000 employees worldwide. And we invest approximately about $500 million every single year in idea generation just in the construction space. So we don't make any blenders or dishwashers or anything like that. We just focus on the construction industry and try to figure out ways for us to truly drive the innovation in this great industry that we are part of. And we truly understand that this industry requires a tremendous amount of innovation. If you think about it, this is one of those industries that has been here since the beginning of times. And right now, about 15% of global GDP comes from this very industry. The construction industry employs about close to 10% of the global workforce. And so with that amount of people and that amount of impact on global economy, it is so important to drive innovation. And for many, many years, this industry has been on a very, very traditional basis. And in the last few years, there's been leaps and bounds of innovation, particularly coming even from here, the Bay Area. And today, I'll talk specifically about autonomous construction and kind of job site robotics and how we can deliver this kind of productivity to the job sites. So I want to take you back to a project that I was intimately involved in. I was in London. This was the year 2014 or so. And we were working on one of the largest infrastructure projects in Europe at the time. This was a tunneling project. They called it the Marathon because it was 42 kilometers under the city of London. This is a very busy city, lots of people going out, lots of people above your heads if you're in the tunnel. And what they needed to do and accomplish during that construction phase was to drill approximately 230,000 holes throughout the length of the tunnel lining. This was an enormous task, and of course, it created a lot of anxiety to a lot of people. And so they asked themselves, how can we do this in a really quick way by eliminating or reducing as much as possible the risk factor for health and safety for the employees, and really do it in kind of a really precise manner. And what they ended up coming to the conclusion of is that really a machine could do that. And so we developed this automated drilling robot that was capable of drilling all those holes and speed up the construction process by approximately 6 months, right? So with this robot that was deployed in the tunnel in London, this was able to essentially virtually eliminate the risk of the health and safety. If you think about vibration on the arm of the humans that are supposed to be doing this drilling by hand, if you think about the dust extraction and exposure that the humans might have, or working at height, these are really complex, let's say, projects. And with this machine, we were able to significantly speed up the process. Now, this was quite a huge undertaking for Hilti. In fact, we partnered with a Swiss organization that was able to help us manufacture the robot, and it was a very entrepreneurial kind of project back then, right? It propelled Hilti to think a little bit broader into the scale of what could we do in the construction industry to automate some of these, let's call it mundane tasks, or possibly just risky tasks or things like that. And back then, we were able to, of course, make it through, and it was a great, I would say, success, but it came with a lot of learnings, right? Because this, as a company at Hilti, we're very highly focused on quality and process orientation, and with this, it was so kind of bespoke. It was not definitely at a mass scale that you can replicate, everywhere as a plug and play. So it propelled us to essentially develop our own business unit for robotics, which we have to this day, which was able to then deliver several different other robotic, let's say, solutions for this industry. So since then, we have evolved quite substantially, and what we're looking at right now is not only some proprietary robotic solutions that we have. I'll talk about a couple here today, but we also have made quite a lot of partnerships. So today, you heard talking about Boston Dynamics as an example. That's a really nice partnership we have with that company. Canvas, you see them here in the picture. And so we started to think a little bit about how can we, in an increasingly, let's say, digital construction project, how can we take the data that is being captured daily? There is a mine of data at every job site that we work on, and really kind of make it work in conjunction with robots, right? In the United States, approximately 3/4 of professional construction companies, they operate in some form of a digital BIM environment, right? And so with that, with all that data that is created on a daily basis on these job sites, the ability to then work with machines that take that data and do something with it on these tasks is huge. The other topic that I'll talk about later today is essentially augmenting human capabilities. Again, we actually talked about it with Professor Khatib here earlier, and it's kind of the same concept with the difference that here we are actually just augmenting on wearable, let's say, devices, capabilities of humans for them to perform the tasks at hand. So let me start with this little guy here. This is called the J-Bot. It's a semi-automated drilling robot that we launched a few years ago, and it's a semi-automated tool machine that is capable to operate in a job site environment where you can imagine there is a ton of material lying around, there's a lot of people and equipment that is kind of moving all over the place. It works on tracks. It is semi-autonomous in the sense that it works with the BIM model to determine where the points and the layout of the anchor points need to be. And then it essentially autonomously goes to those locations, marks the location on the ceiling, and drills the holes into the ceiling, into the concrete, and also collects the dust while doing that. So if you think about it, again, the use of this type of technology helps the operators to essentially be there to check that the tool is doing the right thing, or possibly intervene if the tool hits the rebar, which it's capable of detecting, and things like that. But the rest of the operation is 100%, let's say, automated. Now, with any construction robot, what you're thinking about is really the process that these robots kind of go through, right? So step one is identifying and observing what's the surroundings around them, right? These job sites have, like I mentioned, a lot of material. We have a lot of essentially equipment that's moving around. Every day, the job site conditions might be changing. So the ability to observe is kind of step one. Orienting is step two, to determine what kind of obstacles might be on the way. What kind of path does the tool and the machine need to perform? Number 3 is then deciding, how am I going to get there? What kind of route am I taking to get to my target? And then finally, of course, acting. A job site robot needs to be able to perform whatever task we're talking about, right? So we're talking about possibly painting or drilling, things like that. So with JBot, that's exactly the concept, right? You have an operator that is in a safe environment. It's not being exposed to dust or vibration or anything like that, and the robot is then capable of performing the tasks at hand. When you look at how it's being deployed, so here is actually a few pictures. There were some companies that we heard from earlier. DPR, for example, used this robot here in the United States just a few months ago. And you're then capable to put it into kind of a transportation mode to transport it and ship it over to the next job site. The tool and the robot is being controlled by a robotic total station that determines where the layout points are and how how the tool can then essentially perform the task of drilling and collecting the dust. Now, for any general contractor out there, one of the key differentiators and key actually challenges that they see on a job site is that they have to coordinate all of the different subsets of contractors that are on the job site. With JBot, the ability is that you do a lot of the work beforehand in the pre-planning phase during the BIM model, and then you essentially give that information to the tool for it to be essentially perform all of those tasks across the different subcontractors' space. We call that the clicks before bricks, essentially. So doing the work as much as you can in a digital environment before you actually go into the job site. Now, in some instances, you're not able to deploy a robot, whether it is because the robot has not been designed yet or whether the functionality of the robot isn't quite there yet. In the construction industry, for the longest period of time, workers have been suffering from injuries, whether it's to their shoulders or their backs, because they're performing strenuous, activities. And these activities are, of course, painful for the workers, and they are painful also for the society and for the construction companies at large. They have to spend a lot of money to essentially take care of these injuries. And so Hilti came up with the exoskeleton. This is a technology to augment the capabilities of individuals. It's being used in several other industries, such as, for example, automotive industry. But in the construction industry, it's not been yet deployed on scale, essentially. This is a wearable, kind of like a backpack that you wear. It's only about 4 pounds in weight that you're carrying. And what it does is, as you're carrying a tool overhead, it's transferring that weight back into your spine in a secured way and back to your legs. So you won't feel as much the strain as if you were essentially not wearing the wearable. This allows you to perform a significant amount of tasks, whether it's in the interior finishing trade, whether it's painting or sanding, for example. You've got tasks in the mechanical trade, fitting pipe or duct. In the concrete, environment where you're grinding overhead, for example. This tool and equipment is basically helping the employee feel significantly less strain and therefore be a lot more productive. Now, imagine a world where tools are completely weightless, right? Imagine a world where you're holding a combi hammer that's 20, 30 pounds in weight right in front of you, and you're feeling no weight at all. This is what the XOT version of the exoskeleton does for you, right? It's kind of like a backpack. It has a scorpion-like arm that kind of comes across and in front of the employee. It has a pulley mechanism that detects the weight of the tool and brings it back to zero gravity. So again, the worker that is performing that application, whether it's chiseling or drilling onto a horizontal wall, is completely weight-free. And so again, imagine having all of these workers on a job site deployed that are capable to perform those tasks and significantly decrease the level of fatigue and increase the level of productivity that they have on a daily basis. So to kind of bring it all together, this is such a great industry. It's the industry that kind of builds our roads and builds the hospitals that our loved ones go to, builds the schools that our kids go to, and yet is one of those industries that somehow has been lagging significantly behind other industries when it comes to productivity and robotics. For example, manufacturing or agriculture industries have adopted robotics significantly earlier than the construction industry. In fact, about half of the tasks that a construction worker is performing are told that they're not actually adding a ton of value to what they're doing on a daily basis. It is also a fairly dangerous industry. There are some tasks that, yes, are mundane and possibly repetitive, but some tasks are quite dangerous for employees to perform. Therefore, addressing the health and safety is a significant step in the right direction. And the final piece of the puzzle is in the construction industry, there is just a shortage of labor, especially skilled labor. Some of the youngsters, they have a lot more access to colleges than perhaps they did, a couple of decades ago. Therefore, they may not, join this industry, and at some point it'll hit a point where we just don't have enough people to build the homes and the stadiums and the cities that we want. And so with construction, job site automation, and robotics, we have the ability to essentially address all three of these issues, whether it's productivity on a job site, whether it's significantly improving the health and safety, and of course, addressing the issue of labor shortage and the skill set that the employees require to operate these machines. Now with that, that's the end of my presentation. Thank you so much for having me, and we'll pass it on to you. Thank you.